Hey guys, I got a great topic for you today. We're going to talk about a composition of functions, and I think it's going to be right in your wheelhouse. We're going to try to, be really well organized and be real methodical with our process here today. And I think we're going to feel really good by the time it's all said and done here. So, real quick recap of what you're going to see in this video. These are three examples that we're going to try to tackle throughout the video. So, can we find g of f of -2? Could we find g of f of x based on those functions? And then something really new that I want to probably emphasize more than anything else is, what if we get the final result? What if this is what the composition looks like when I'm all done? Can I decompose or work backwards to identify the original g of x and the original f of x? But if that sounds a little scary, that's okay. That's the end goal of what we're going to kind of build up to. So we're really focusing on, let's see, some of our early definition work here. So what is the composition of functions? So first of all, the composition of the function f with g is denoted by, we could say f with a little circle that says of, we'll put those in parentheses, and then an x in parentheses. So that's like saying f of g of x. Or the one that I'm going to use in the video today is written like f of g of x. So it's important. I want to emphasize those are equivalent. It doesn't matter which version you see on a quiz or a test or homework, whatever the case. So if I say f of g of x, that's equivalent to saying f of g of x, something like that. And that expression, when you see f of g of x, it's going to be read just how I'm trying to pronounce it here, f of g of x. And that magical word of is pretty special. And one of our main goals today at the end of the video is hopefully being able to recognize the difference between the multiplication of two functions versus the composition of two functions. So the multiplication would say f of x, g of x. So now you're multiplying the two, but a composition says it's f of g of x. So hopefully you notice like a little difference in there. And some terms you're going to hear me use over and over again, hopefully, are either the phrase replace or substitute. So that's what we're going to get ourselves into. So I've got this fun little picture to try to support what I'm trying to do here. And this is going to be a really nice warm up. So we've been given a function or a rule, and we want to evaluate f of 5. So we're going to take the x and replace it with a 5. All right, so this x right here is going to get replaced with a 5, and then we're going to evaluate. So 20 minus 1 makes 19. So really what this picture kind of does for us is it says, okay, what was the original input? In this case, the 5 was. So I'm thinking, okay, my 5 was the original input. We put it into some function machine. In this case, the machine was 4x minus 1. And as you do all the crunching, boom, 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 it spits out an output, which in this case was a 19. Now we're going to kind of take that idea to the max here as we start to do a composition of functions. So you start with your first input, you plug it into some rule, and you get an output just like we did. But instead of being totally done, that's only the halfway process. This output of g becomes the input for f, who then spits out a new output. All right. And I think this is the real pivotal point right here. So whatever the output was for the first function becomes the input of the second function. So let's see if I can move this. There we go. Okay. So first things first here, let's unpack this notation right here. We're going to take -2. We're going to substitute it into f. That's going to give me my first output. And then I'm going to substitute that number into g to get my final answer. So what does f of -2 look like? It's going to be 4 multiplied by -2 minus 1, which is going to make -9. And now, so that's right here. We're sitting right here at -9. So we started with -2. Now we've got this -9. I need to plug that into g. So g of -9 is going to be 3 times -9 squared minus 2 times -9 plus 5. And let's see what that makes. That's going to make a good old 266. So that this final output would be here 266. That's my final answer. So things are really nice as long as the inputs are, that first input's a number, everything else really flows. So now the challenge is, what if that original input is not a number, but now it's a variable? So let's unpack this guy right here. We're going to take an x, we're going to substitute it into f. the output is probably going to be some function of x, and it's going to be in terms of x. And then we'll substitute that answer into g. So here's what it's going to look like. F of x is kind of the funny version. That's just basically, I guess we're saying, hey, let's replace x with an x. So nothing in this function is going to change. So that first output is going to be 4x minus 1. So this first output then becomes the input for the next function. So now we want to evaluate g of 4x minus 1. And here's where it gets fairly intense. So each of these x's here is going to get replaced with the quantity 4x minus 1. And that's just something we got to talk ourselves through. Just keep thinking substitute or replace. And now the order of operations is going to kick in and be really, really special. Because of this squared sign, I'm going to rewrite the 4x minus 1 a second time. If you want to, you can go ahead and start distributing that too. No big rush there, I guess. But so now what I'm going to do is I'm going to FOIL these two right now. And that's going to leave me with 16x squared minus 8x plus 1. I think I might as well combine the 2 and the 5 while we're at it. And then I'm going to swim upstream here. So I'm going to distribute the 3 to make that 48x squared minus 24. I'm sorry. Let's make that a 24. Just kidding. There, all right. Plus 3 minus 8x plus 7. And 48x squared minus 32x plus 10 for my final answer. So got a little intense there, but nothing we can't handle. Now, here's the really brand new stuff. We're going to try to reverse engineer that process we just went through. So if we see the end result, so to speak, this is the composition of two unknown functions right here. Can we reverse engineer that? So a lot of times, let's think of it this way. Let's think of h of x as being defined as f of g of x, okay? And so think of g of x is the inner function. Here's my inner function, and then we'll consider f to be the outer function that g got subbed into. So a lot of times if I can just say, okay, who's my inner function? If you could imagine there being a parenthesis here and here. So my inner function is going to be that 4 minus x squared. And then your outer function in this case is going to be radical x. So you can imagine, knowing that, if you had to find f of g of x, you would take this guy and sub it in and replace that x right there, which matches the original problem. So this technically is our answer. That's the process we're trying to reverse engineer it. Let's take a look at another example because that can be kind of overwhelming. Okay, who's our inner function? Who's our outer function? So my inner function is going to be, this little rascal. Sometimes there's parentheses, and that makes our job a lot easier. Whatever's inside the parentheses is the inner, whatever's outside the parentheses is my outer. So let's say g of x is going to be the x cubed. That's my inner function. And who did that get subbed into? It got subbed into the cosine of x. So imagine this x right here getting replaced with x cubed. It would make this answer up here. All right, we're cruising, huh? We're cruising. Hopefully not going too fast. All right, so who is my inner function? So I'm going to start with what's inside the parentheses there, cosine of x. And notice how similar this one is to the previous example. And I tried to back these up next to each other so you could see how just kind of moving that cube sign just a little bit could totally change the whole complexion of the problem. And who did that get subbed into? It got subbed into the function x cubed. So imagine this. Imagine this. What if we took this x and replaced it with this guy? We'd end up with this result. All right, one more to practice on. Never a terrible idea to try this on your own real quick. Just tap that pause button real quick. And so who's my inner function? That's going to be the 2x minus 3 rascal. And who did that get subbed into to create that final version? And it got subbed into the x to the fourth function. So again, imagine taking this x and replacing it with this guy right here. You'd end up with this function when you're all said and done. So I hope you felt pretty good by the time we're all done there. We're going to get some more practice and continue to build some confidence. And before too long, we are going to be experts at decomposing the composition of two functions.